Now class, today we will study about the ultraviolet visible spectroscopy. In this ultraviolet visible spectroscopy, we get the absorption and the reflecting spectroscopy in the range of ultraviolet visible spectrum, and this is the block diagram of the ultraviolet visible spectroscopy that contains the source, a monochromator that can be in the prism, filter or other source of the monochromator, and these are the beam splitter which gives the splitting of the beam, and it goes to the sample and the reference. These sample and the reference, in the sample is the sample in the solute form, and this reference is the solution solvent form, and they are taken in the solution form. They are given to the detector. That detector will detect in the photoemissive cell, barrier cell, and they will detect the spectrum, and then the ratio of the solution and the solvent is taken, compared, and then the indicator is there which shows the output of the spectroscopy. So these are the instrument component, that is the source, wavelength, sample containers, detector and signal processor, and readout, that is containing the indicator. This is the another block diagram, the simple block diagram of the UV-vis spectroscopy, that is sample, solvent. I discussed it earlier with this slide, and it has got the radiation source, wavelength selector, that is the monochromator that can the monochromator that can be prism or filters form, that is give whatever the radiation are absorbed or reflected, that is given to the detector, and then there is the indicator to indicate the spectrum. It has got the same component that I have discussed in the previous slide. Now what kind of radiation source or the things we have to take as compared to the radiation source? We have to take the source which has got the all wavelength, and it should be sufficient power container. There should be appreciable changes in the intensity at the radiation at different wavelength, and the intensity of radiation should not fluctuate for longer time, and there should be no scintillation of the intensity of the radiation. This scintillation means that there should be no change in the phase and amplitude when they are falling on the sample. This dispersing devices, that is the monochromator, and this dispersing device, we have what happens with this, we have to take all the we have to take the wavelength of the source, and we will allow only this particular wavelength which is required for the UV-vis spectroscopy. Others will be rejected. In the next slide, in the next slide, I will tell you about the merits of the monochromator, that depends upon the effective bandwidth, peak percentage transmittance, and central wavelength. This is the transmittance versus wavelength graph. In this, the maximum peak is there, and this is the effective bandwidth, that is the central wavelength is there. On the left hand side and right hand side, we are having the wavelength band, which is the effective bandwidth, and it is defined as the width of the transmitter's band at half of the maximum transmit. That is the what maximum transmitter is this, its half is this. So this is the effective bandwidth. Peak percentage, it is the percent transmitters at the central wavelength, that is what is the peak percentage value of the transmitters. And central wavelength, it is the wavelength corresponding to the center of the effective bandwidth, that is the center of the effective bandwidth. So these are the merits, these are the point that merits out the that helps in the determination of the merit of the monochromator. And as I have discussed, that monochromator can be filter, prism or grating. This grating, you all are familiar with the laser grating experiment that we used to do. Now what kind of test sample and what kind of optical materials we can use? Your test sample should be always in solution form, and the solvent should be there, and the test sample will be contained in a container that should be transparent to the radiation. The solvent should be in such a form that it should not absorb the wavelength of the radiation, and it should be also transparent to the electromagnetic spectrum radiation for a particular region that we are using for the spectroscopy. The radiation detector and the indicator. This radiation detector and the indicator are the devices that detects the radiation which is coming out after the sample is being under the experiment, and it detects, that is detected by the barrier layer cells, photoemissive cells and photomultiplier cells. So what are these devices that we will discuss in the part 2 of ultraviolet visible spectroscopy. Thanks for today.